Hi everyone, thanks for joining again. Today I have something very exciting I'd like to share with you, and that is how you can total up values that you may have stored in your model. And those values may be in places such as tag values of stereotype attributes, or they may be in value properties somewhere of blocks. And I'll be showing this in version 2021X as well as 2022X. So for this first example, what we have is a stereotype that we've named cost item. And as you notice, it has a meta class allowable to be applied to any element. And then we have 3 attributes, and those attributes are cost item 1, cost item 2, and cost item 3. And if we look at the model of what this has been applied to, we've actually gone in and set the tag values for these as 2, 2, and 2. So we'll be attempting to add up the values of 2, 2, and 2, which obviously should equal 6. Typically, the way you can get to these tag values are if you go to your blocks and then you look at your tags, and then you notice here we have these values here, which we could go in and change by creating the value and setting it through the specification. But we can also set those in a table as well. So let's go ahead and look at the derived properties that we're using to do this. If we notice, this is the result that we would like to have. There are 2 examples here. One of those is if you were to attempt to total all of these stereotype attributes or all of the tag values. The other example is if you only wanted to total up a few selected properties and not the entire group of tag values. So let's go ahead and dive into how you could accomplish something like this. We're going to go to Edit Derived Property. If you notice, starting out, the output type for this derived property is the primitive type of real. Anytime you're using derived properties, I'd recommend using the primitive types and not the value types. That should save you a little bit of heartburn in getting these values to actually output. So starting off, we're using a script. And you can do that by going to Create Operation and selecting Script. So then let's dive into some of what is happening behind this. So for the script, notice the language here is OCL 2.0. That's Object Constraint Language 2.0. And then the script for this is arg1, which is the input, and that will be this block, dot tagged value, dot value, and then parentheses. And then we go to .ocl as type real, and what that does is converts this to a real number, and then you have to use this notation, the dash greater than and sum with open and closed parentheses. And what you'll get as a result of that is the total of that, which is extremely simple, and that's a very nice way to go about doing this. Something else I'd like to point out here is how you can use this evaluation mode if you've never done that. So this is a way you can actually check what the results of your script will be without having to close out this structured expression window. So notice if I just click evaluate now, nothing happens, but then what you can do is actually go to the argument and pass it a specific object as an argument. And in this case, we'll be using that system block. So if you open up the argument selection, you can find whichever specific element you'd like to perform that operation on. And then you can select that. Notice it says argument now, and then we can go to evaluate, and we have the result of 6. And that sounds simple enough, but if you attempt to do this in some other ways, the big issue that you'll run into is that anytime you are dealing with duplicate values, such as 2, 2, and 2, what will typically happen is any of the values that are duplicates will be ignored. So you might get a result of 2 rather than a result of 6. And that is obviously undesirable. The nice thing about what this does is it allows those duplicates, and then you can total up all of the values that you'd have in that list. So the difference is whether or not you're dealing with a set, which typically has the value of is unique set to true, meaning those values would be ignored if they're duplicates, or if we're dealing with what you would consider a list, or in OCL, that's actually considered a bag. So that would then include all of the duplicates, and then you'll end up with the results you're looking for. Now let's look at this next column where we have total of 2 of the items, And this gets a little bit more interesting if we only wanted to select some of those items or some of those tag values or stereotype attributes to add up. So let's go to Edit Derived Property and look at how we arrived at this. Notice the script for this is still OCL 2.0. However, it's quite a bit different. So we can walk through. We have argument 1, which is still, if you look in your containment area here, argument 1 equals this, and this is considered a contextual variable, but this is really referring to that base element. So if you had multiple rows in this table, each of those items in those respective rows would be considered this, and it's essentially the starting point. So it's saying start with this element and then go from there. So that's what a contextual variable is really referring to, is that beginning base element that's in your meta chain. So notice we're just leaving it named arg1, but you could rename that, and it's then considered a parameter of your script, and you can then use that in the script. So we have arg1, which is that system block dot tagged value, and then we're going to select specific items that are tagged values, because if you were to simply have tagged value, it would actually include all of those tagged values. So this is actually considered a collection in OCL. Anytime you have the dot notation, what it will do is return a collection of things that are tag values in this case. So the shorthand notation in OCL for doing a collection is actually using the dot, whereas you could also do that expanded and have the dash greater than and have the collect with the open and closed parentheses after that. So instead of having to use collect, you can use the dot notation. I digress slightly. So let's go into what else we have here. So we go to select, and then notice we have this X and then the vertical bar and then argument 2. So we're going to be using another argument here, and we'll delve into that. And notice then we're going to includes X with closed parentheses after that, and then dot value. So that dot value is important because the tag value will only get you so far into that data that you're actually trying to get at. So if you look at the stereotype attributes, it has a tag value, but that is essentially the elements that are named those tagged attributes. If we're trying to get at the values, however, you have to actually use the dot value to navigate to the value of that. And then notice we have open and closed parentheses, and then we're converting those to real numbers as well, because typically that would be a string. And if you added up a string of 2, 2, and 2, you'd actually get 222, not 6. So we're converting that to a real number and then using the sum operator after that as well. So let's delve into argument 2. Notice argument 2 is actually a filter. So if you were to try to create a filter, you could, at that argument that we're naming argument 2, which is essentially another parameter, you go to create parameter and then use a filter. That's what we did here. Notice, however, the input to the filter is the meta chain. So it starts out at that stereotype and it goes to the tagged value. And then for the predicate, which filters have, notice we've selected a nested operation. And then for the body, we're using a contains operation. And then this is provided to you named arg already. So then the input for this is a collection. And then notice we're able to actually select which of those stereotype attributes we want included in the collection. So to do that, you would actually go to create operation and use the option for element, and then you can search for those elements. So if we were to create another one, you could go to element here and then simply search for one of those stereotype attributes. Notice nothing pops up until you select property. And if we wanted to include cost item 3, you could do that by searching for it there, and then that would also be included in that list. So because we're not using that in this case, I'll simply delete that. However, let's keep going, because notice we have another part of this, and that is this first operation. So if we're to collapse this, let's go back to, we have the predicate is the nested operation. It's a contains operation, and the contains operation is essentially a Boolean expression that will return true if all of the expected items in that contains are in fact there and they exist. So what you see is we have the collection, it's evaluating this collection, and then we have object equals a first. So now we're using a first operation, going to input equals meta chain, and then notice the context here. Instead of using this, we're actually using that arg value for the context. And then we're actually starting with the tagged value and then going to the tag definition. So that is a property of a tagged value, and it's called the tag definition. So all of this put together allows you to essentially select down to those specific stereotype attributes or those specific tags of that stereotype that you would like to include in that sum. And that works very well when you complete that. So that is the method. I know that's drawn out and it's a little bit complex, but I'm happy to provide that to you guys because that is obviously not something that would be intuitive at all. However, this next section I'd like to go into is how you can actually do similar thing in a very different way. And in this case, it'll be if we were to use value properties. So notice in this first example, we're using stereotype attributes. In this example, however, we're going to be using value properties of a block. So notice we have a car and it has some various parts. So what we're going to do is essentially assign values of mass, or we are going to cause each of these parts of a car to inherit the value property of mass, and then we can total that up in a table. This is a very different way of doing this than a mass rollup pattern. And typically I would recommend actually using a mass rollup pattern if you're attempting to do a mass rollup or a cost rollup that actually traverses different levels of your architecture. And that's because the mass rollup pattern is actually recursive. However, in this case, what we can do is actually query one level at a time. So we'll be making a derived property that will essentially query this level of the architecture, and it will total up everything that is below it, and then it'll go up to the car, and we'll have another derived property that will be totaling up this level of the architecture as well. So this really is a great way to do additions or sums if you're dealing with a flat architecture. And that is the one big difference between doing a mass rollup using a rollup pattern versus what we're going to do here. So keep in mind, you can use this for other things besides mass rollup patterns or mass rollups. This could be done for, if you had budget items and each of those budget items or each of these things were attached to some type of a budget, for example, you could use this for that as well. So this is going to get a bit complex, but this is how you could actually go through and do summations of different values that are in your architecture. So notice we have this block up here that I will rename a mass object. So in this case, we have this block that is called mass object, and it has a value of mass that is currently not typed, but for now that is okay. So each of these things are inheriting the value of mass, and then these are actually redefined properties, even though we're not displaying that they are currently redefined. So notice each of these have their own mass, and what we'd like to do is total these up. However, if you look at the architecture, notice we have below the car, we have chassis, body, transmission, and engine. And then if we look here, we have those items as well that are directly inheriting that mass property. So let's delve into how you can accomplish something like this. Notice we have a few different custom opaque behaviors that are in the model, and those will actually be called out as part of the expression. So we have this one here that you don't typically have in your out-of-the-box model, and it's called map for lists. So I will be happy to share this model with you if you are interested. But if you look into this here, it's got a kind of buried expression. We can open this up and notice the map for lists is a JavaScript Rhino script, and it looks like this. And the interesting thing about that is that first line, how it has .array list, and that's the important thing, so that it will not drop duplicate values. You do not want a set in this case, you want a list that would include the duplicates, and that's what this script will do for you, is allow those duplicates. So then notice it has an input, and it has a mapping operation. So we'll see how that's used in a minute. We will be using this operation quite a bit, and this is also a custom opaque behavior that is called retrieve value property value. And what you can do with that is actually select specific names or specific types of value properties that you'd actually like to operate on. So in this case, we will open this up, and if you go to the body and language section of this, it's using a first operation with a meta chain, and it's doing an intersection of a few different things. So notice we have an input of a meta chain, and for the context, instead of having this as the context, you would reset that and use an intersection operation, and then go from the class to the member. And then for the context of this is actually set to a block, whereas the next part of this is another collection that uses a meta chain, and it goes from the property to the property of redefined property. And that's specifically because in this case we're using value properties that have been inherited and then redefined. So that's where this comes in, to specifically be used in a case where you're actually inheriting properties. And then if you notice, the context of this is a value property. So that is the really important part of how you could do this type of a summation using the retrieve value property value that uses inherited value properties. And then notice the other one, which is also a customized opaque behavior, is this sum expression. And this is one that had always made me scratch my head a little bit because it doesn't seem very intuitive. Notice it simply says sum, and it has two parameters, x and y, that are not even typed as anything. However, if you look at the body and language section, it's a JavaScript Rhino script, and it simply says x plus y. So you would think that you could only add two values with that. However, it will actually total up all of the values in an array because it's going to be used with a reduce operation. So let's delve into what is actually going on here. So at first, in this type of an architecture, what you would need to do is collect all of the subparts or the subcomponents. So in this case, we're using a derived property that calls this the subcomponents, so we can edit that derived property. And notice we have a meta chain, and the context is this. Notice as well that the type or the output type of this is a meta class of type. So that's a bit interesting. It starts at a block, goes to an owned attribute, looked at part properties that are owned attributes, and then their type. And that is what returns the subcomponents. Let's go on to the next column that says subcomponents of strict order. In this case, we're using the map for list. So we're now putting into use that map for list. And if you were to try to do that from scratch, what you do is then go to create operation from model, and you'd be using that customized map for lists, and you'd then have that to choose from there. So you could go to map for lists, and notice it looks at an input and then the mapping operation. So for the input, notice we have get element feature value. So get element feature value is another interesting opaque behavior. And then if we look at the get element feature value, what you would do to get to that point would be to go to the input, and then you would go to operation from model and search for get. Notice you have the operation now that is called get element feature value. So what it looks for is a context. So in this case, we have element equals unspecified. So in order to make this say the context is this, you could reset this and then set it to a contextual variable, and that's what changes that to say this. So then obviously for the feature name, in this case, it's actually looking for a string. So it'll be going from that block to its own attribute. and then the mapping operation, which is actually a nested operation. So notice down here we have mapping operation equals null, and then what you typically would do, it would be to go to nested operation, and then it's looking for the body. And in this case, we have body is get element feature value. So we can continue by selecting another operation here and say get element feature value. And then it's also looking for a name. So in this case, we have the element feature value. If we expand that, that is then set to a part. So for this, where it says element equals part, notice down here, right now we have this arg that is simply named arg. But what you would want to do is actually rename that, and we could call that part. And then for this element equals unspecified, we will select a contextual variable. And notice it now says element equals part. So you then have this drop-down menu to select that context. In this case, we'll be using that arg that we've renamed part, and we'll be selecting that from the drop-down. And then we have feature name. And in this case, we're using the lowercase type as that feature name. So this is what would produce a strict order of subcomponents, and then we have that name that we can then use as a variable in the next expression. So subcomponent strict order is now the name of a property of a block because it's a derived property. What I'll do is close that out, and then let's open this to where we can actually see all of these values before we get to the point where we actually go to sum them up. So let's go to edit derived property. Notice this starts out and we have the output type is real. We've named this subcomponent masses of strict order. We start out with a map for list, and then we have an input of get element feature value. Notice this is a contextual variable again set to this with the feature name subcomponent strict order. Now we can call out the name of that property because it's a derived property of the block. So then that is considered text in this case. And then notice for the mapping operation, we use the nested operation, and then the body of this is actually a first operation. So you would select that from the operations list. And then for an input, we're using the retrieve property value opaque behavior. So that's the retrieve property value opaque behavior. And then notice this is another contextual variable. It has the C next to it. The way you get that is by naming this, which would begin saying arg. You could rename that component if you'd like, and then resetting that, selecting the contextual variable, and then you'd have that available in this drop-down menu. And then notice for the element of this, it's a value property that you could then search for in this list, and we're using the one that is inherited from the super type that is named mass object. So mass object is the name of that supertype block that has the property of mass, and that's the value property mass that you would actually want to select. And what that produces is all of the values, and notice we are allowing duplicates in this case as well, which is very important. If you did not allow duplicates, this would ignore the two values that are the same, which in this case are 30 and 30, so you'd not end up with this total. So now let's look to how we can actually get the total of these subcomponents. We'll go to edit derived property, and this is where we actually get into using a reduce operation. So output type is primitive type real. Notice this has a single value as an output, and for the input we have a get element feature value operation, and this is a contextual variable set to this. And then for the feature name, we're now calling out the subcomponent masses strict order property. Simply calling that out by name now because that is a derived property. And then notice this is a script, and it's a reduce operation. So the reduce operation is simply JavaScript Rhino. It says x plus y, and each of these are set to x plus y. And what you get when you use that is then the sum of all of these subcomponents. And notice in this case we have 97, which is correct for all of these values added up. And then if we wanted to go up to the top level, let's delve into the component mass. And notice it simply is looking at the block being this, and then the value property of the mass. So that is how you can do 2 plus 2 in Cameo Systems Modeler. I know that is not straightforward, which is why I wanted to offer this to you guys. And hopefully this will help out if you're attempting to do some derived properties or you'd like to sum values in your model. If your team is in need of MBSE expertise, please feel free to reach out to STC, and our team of model-based systems engineers would be happy to help your team. Thanks a lot.